range sensing applications are very important these days, and when combined with AI, you can do all sorts of interesting things with it. But there are different technologies that are involved. Can you tell us about some of the ones that Infineon is bringing to the fore?
Yeah, absolutely, Bill. What Infineon is doing is we have a sensor portfolio line what we call is 3D sensing, and that 3D sensing is actually the depth perception that we get with the range sensing. So with radar technology, we're able to do that with 24 gigahertz and 60 gigahertz radar, as well as 3D time of flight technology, imaging technology that basically takes a time of flight technology to calculate the range of a particular object, capture it, pixelate it, and present it as a low resolution image with depth data.
Okay. Now you have a neat little package here for the radar demo.
Here is a demo that exemplifies our 60 gigahertz radar. The radar is actually very small. It's in this little opening here. We actually cut out this demo such that we could see the actual chip with the antennas in package, and you could see that through here. And what we're doing is we're actually enabling a gesture suite with this sensor on an embedded microcontroller. This is just providing USB-based power, but you can plug this into, let's say, a USB power cell, and it doesn't require any intelligence outside what's embedded into the microcontroller here itself. And it's controlling a light array here with LEDs. So if I were to, let's say, swipe my hand from right to left here, let's say, it would be able to track that. Left to right, up to down, down to up. And then if I want to do a push motion, it would be able to recognize that. Again, the idea is that if I had a sensor that was, let's say, mounted on a wall or somewhere with enough distance where I can gesture to it, I can be able to control certain things in the house like AV, entertainment, lighting, HVAC, heat, AC, and so forth.
Okay. The other technology you mentioned was time of flight. Could you talk a little bit more about the technology in the demo we're going to see here?
Yeah, the time of flight is basically it's a indirect time of flight technology where you're looking at the travel of capturing an image using nanometer wavelength light, and doing that we're able to encapsulate and pixelate that image into a low resolution image where we can use to articulate where that presence is from a depth perception. And we can overlay that on top of a camera image so that we can make a camera more accurate in terms of the depth perception and apply it to cases where authentication, for example. We've partnered with a company that is able to put the software together to fuse RGB camera with our time of flight technology. The module is basically here with our time of flight imager here and an RGB camera that's here. And basically it's fusing together the RGB camera's image as well as the depth perception from the time of flight camera to provide a 3D like image here. So here we're able to control that to determine what the distance is of me relative to the camera, and I can control the ranging of that and determine how far I can be out to about 8 to 10 meters. But as you can see here, we're able to apply this to a anti-spoofing for, let's say, a 2D camera where we have the depth perception to provide additional security for an actual face that is looking to enter a secure area, or other applications where you have a need to understand where an image is relative to how far it is from a reference point. And in this particular demo, we're basically integrating our time of flight technology with just a standard RGB camera to show that we can combine and fuse together a camera image with a depth data to really show a 3D view on a screen.
Okay, so what are essentially the trade-offs between the radar and time of flight? How would a designer choose one versus the other?
It depends on what they want to achieve as far as resolution and accuracy for face authentication or recognition, for example. In order to have a 3D authentication rather than just using a camera, it would require more processing, more data processing. You're looking at integrating computer vision, perhaps with the camera, but also with the time of flight itself. It's basically capturing data, a lot more data with the pixelization that it needs, and of course it is requiring a little bit more power than what radar is. Radar, again, we can get down to a single-digit milliwatt power in an embedded solution. So from a size and cost standpoint, radar, even though it doesn't give you the resolution, it certainly can be applied for certain needs in terms of presence, occupancy, and distance ranging as well in a more cost-effective manner.
Okay. Well, I think a lot of people know that radar is being used in automobiles, but it sounds like there are a lot of other applications where your systems can be utilized.
Yeah, absolutely. It started off with the military, of course, and then it got evolved into like speed detection and ranging in cars and automobiles, safety in ADAS for cars currently as we have it now, but also consumer applications. We have it down to where radar is so miniaturized with the antennas in the package at a low cost point, low power point, such that it can be embedded into a battery application, a solution that where you can have a sensor that you can put into a doorbell or a camera or a light sensor, where it can be literally a placement of PIR sensing with more intelligence.
Very good. Well, thanks very much for telling us about various range sensing solutions.